Today's lesson is modeling with fractions. So we'll look here at the first slide. First, we're going to be looking at a function table, and we are going to be writing the rule that the table follows, which could also be called the equation. So the best way to do this is to look at the table and look at the input, which is the x value, and ask yourself, how do I get from 1 to a negative 2? Well, there are a couple of possibilities. 1 times a negative 2 equals negative 2, or 1 plus a negative 3 equals a negative 2. So let's see which one of these rules would work with the other inputs. You have two choices, multiplying by a negative 2 or subtracting by 3. If we take the next input, which is 2, and we multiply times a negative 2, that would make a negative 4. That does not work. If we take the 2 and we subtract 3, that would result in a negative 1. That works. Let's just see if it works for the next two inputs. For 3, if we subtract 3, that would make a 0. If we take 4 and we subtract 3, that would make a 1. So that is the rule that we're following. So we write the rule, y equals, how do we get the range? That's the y equals. We took the x value and we subtracted 3. This is called standard form when we write it like this. We also want to learn how to write it in function notation. To write it in function notation, all you have to do is replace the y with the f of x. This means that this is a function. Remember our previous lesson, a function is a relation or a group of ordered pairs where the x never repeats. It works just like the equation that has y equals. We're just replacing it with f of x. So it looks like this. Here's another table. We're going to look for a rule. Look at the x right here, the input. We say, what do we do to 1 to get to 3? Well, you could add 2, or you could multiply times 3. Which one of those works for the rest of the table? If we add 2 to this one, that makes 4. That does not work. But if we multiply times 3, that equals 6. That would work. Let's check it here. Multiply times 3, that would be 9. Multiply times 3, that would be 12. So that works. So we write that as y equals 3x. And to write it in function notation, we replace the y with f of x. The next one is on your notes. Now for this one, if you look up there, it may not look as easy because you can't think of anything, any one step to do to the input, which is the x, to get the output. This is actually going to be a two-step equation. So if we look up here, and we think, what could we do? I'll pause a moment while you think about it. This one's actually going to be a two-step one, where you're going to multiply the input times 2 and then add 3. This would be 0 plus 3 is 3. 1 times 2 is 2, plus 3 is 5. 2 times 2 is 4, plus 3 is 7. 3 times 2 is 6, plus 3 is 9. To write it in function notation, you simply replace the y with f of x. This one is not on your notes, but it's good to practice. This is a one-step equation. If you look at the input, you will notice that the output, or the y values, are less than, so you're either going to be dividing or subtracting to get a smaller number. This is one step, and all you have to do is simply divide it by 5. So in standard note form, that would be y equals x divided by 5. And in standard notation, that would be f of x equals x divided by 5. Now we've been learning some terminology. We're going to add one more word to our word bank. We've been talking about the x and the y and different names associated with those. The input, which we also call the x or the domain, can also be referred to as the independent variable. The output, which we also call the y or the range, is the dependent variable. And we're going to see how this works on some functions coming up, but for right now we're just working on the terminology. So on your notes, down here, x can be referred to as the input, y is the output. The x can be referred to as a domain, the y is the range. And the new word for today is the x can also be called the independent variable, and the y is the dependent variable. And on our second pages of notes, we're going to be looking at that. Here is a real-life situation. In the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. There are two variables in this, the amount of electricity and the temperature. One of those is dependent on the other. Either the amount of electricity is dependent on the temperature outside, or the temperature outside is dependent on the electricity. Well, in this scenario, the amount of electricity used is dependent on the temperature. Now, remember, the independent variables means that this was the x-axis, this was the input, the domain. This is important because when you're graphing it, the x-axis is the horizontal axis. So if we were graphing this, the temperature would go down here on the x-axis, and the dependent variable, which is also the y or the range, is graphed on the y-axis. So the amount of electricity would be on the y-axis. It helps you know which one you put on each axis. Another scenario, the cost of shipping a package is based on its weight. Is the cost dependent on the weight, or is the weight dependent on the cost? The amount that it costs depends on the weight. So the weight would be the independent variable, or the x value, and the cost would be the dependent value, or the y variable. The faster Ron walks, the quicker he gets home. We have his speed, and we have his time. Is his speed dependent on his time, or is his time dependent on his speed? The amount of time depends on his speed. So in graphing this, our independent variable, or our x variable, would be speed, and the time is the dependent variable, or the y, or the range. A painter must measure a room before deciding on how much paint to buy. Is the measurement dependent on the amount of paint, or is the amount of paint dependent on the measurement? The amount of paint is dependent on the measurement. Now we're going to take it one step farther. We're going to identify the independent and dependent variables, and we're going to write an equation in function notation. You've written equations before, so just think about how you would write this equation. A lawyer's fee is $200 per hour for her services. A lawyer's fee is $200 per hour. This is where we're going to be multiplying it times x. So the fee, which is the y variable, is dependent on the number of hours that you work. So we write our equation like this. Now, we talked about function notation. To put some meaning behind our variables, a lot of times instead of using x as our variable, we ask ourselves, well, what does that x actually represent? It represents the number of hours, so we could use the variable h just to give some meaning to that variable. If we use h, when we write it in function notation and write it, instead of writing f of x, we are going to write f of h, function of h. Whatever letter you use here, you must use here. If I want to use h for hours, then I'm going to say f of h is 200 times h. That's how you would write that in function notation. A math tutor charges $35 per hour. Well, the charges are $35 per hour, and that was the charges. So the charges are the dependent on the number of hours. Now for function notation, instead of writing a y, we're going to write f of whatever variable we had in the equation. F of h equals 35h. If you're uncomfortable with using h and you really are fond of x, then it would be f of x is 35x. Remember, x is just standing for an unknown number. It's just sometimes helpful to put a variable there that helps us put some meaning behind it. A fitness center charges $100 initial fee plus $40 per month. So $100 plus $40 per month could be written in function notation as f of m equals 100 plus 40m. I used m to stand for months. If you wanted to use x, just make sure you use them in both locations. But months gives you more meaning behind the variable. The last part of this lesson, we are just going to be plugging in numbers to an equation written in function notation. So here's an equation. F of x equals 5x. So we're just working here on the right side. And it's going to tell you what to plug into the equation and to solve it. So this is f of x equals 5x. So we're going to plug in a 6 to x in that equation. When we do that, f of x equals 5 times 6. And of course, 5 times 6 is 30. So f of x just equals 30. If we replace x with 7.5 or 7.5, this time we have 5 times 7.5, which is 37.5. So you're just plugging in numbers to the function and solving. That would be, if you're making a table, that would be 2 numbers for your input, because your x is your input. These are your inputs. And the y, which is the same thing as your f of x, that would be your output. Another example. Again, here's the equation you're working with. And it's just telling you what number to plug in. So in our first one, g of t, we're just going to plug in 2 to t. So that would be 230 times 2 plus 10, which is 14 and 6 tenths. On the second example, we're just going to plug in negative 5 to the equation. When you do that, you have 2 and 3 tenths times negative 5 plus 10, and that gets a negative 1.5. Just plugging in numbers and solving. This one is on your notes. Again, here's the equation that we're plugging into. First time we're going to plug in a 1. Second time we're going to plug in a negative 3 to that equation. So with the first one, when we plug in a 1, it would be 2 times 1 minus 1, which is 1. In the second example, we're going to plug in a negative 3. So that would be 2 times negative 3 minus 1, which is negative 6, plus a negative 1, which is negative 7. That, I believe, concludes our lesson on functions today.